So we're going to do a migration demo for the 5069 SDN going from a 1769 SDN. The hardware we're going to use is starting with a 1769 controller and an SDN card attached to a 1734 PDN, which is a .io device, DeviceNet backplane. We'll have 3 .io devices that each will have an individual address on the DeviceNet network. Those will, again, when we make the conversion, we're going to wind up with a 5069 controller and a 5069 SDN with the existing PDN network. And we should be able to, once we're finished, be able to take that connector and plug it into either the 5069 and see the process continuing to work, or plug it into the 7069, and either one would continue to work. We're making the assumption that you have the 1769 controller in front of you. There are some considerations. If you don't have that existing hardware, it's failed or whatever, hopefully you at least have the configuration files, both the ACD as well as the DNT file that you use in RSNetWorx. So some considerations: you should have the AOP installed for the 5069 SDN. If the controller is available, then we'll be online with it, the 7069, and we can use that within RSNetWorx and RSLogix. If not, at a minimum, you should have the old ACD file that goes with that, the old RSLogix project file, as well as the DeviceNet file for RSNetWorx. We're going to proceed as if everything's online, and you'll see that here in a minute. Make sure that you have saved a copy of that somewhere, that ACD file for the 1769, because we are going to make some changes and save them to a different version, and you can go back to that. In some situations, you may have a 1784 U2DN module. It's basically a USB to DeviceNet interface that allows you to have your PC connected to your DeviceNet network and allows you to do configuration. In our case here, we're going to just use the SDN cards as basically our pathing to get into the DeviceNet network to do our configuration. But something to consider: if you do a lot of device network, you may want one of these U2DNs. The 5069 SDN will default as an out-of-box from manufacturing to address 63 and a baud rate of 125K. We will need to do a node commissioning on that to change it to an address that we want to use within our DeviceNet network. In my configuration, my 1769 SDN currently is at address 61, MAC address 61, and I'm going to go ahead and change the 5069 SDN. I'm going to give it an address of 62, and we'll go through those steps here in a minute. The demo project, basically for the migration, consists of a controller, an SDN scanner, the 1734 PDN with the 3.io modules. And what I've got is a program within the 1769 right now that just cycles through I've got 2 output cards, and it just cycles through a number between 0 and 255 and then back down again. It just goes up and down, and that allows the LEDs on the front of the 2 IO cards, an OW4 and an OW8, I think, just blink. And so that gives me an idea that the process is running. And what I expect to happen at the end of this process is, once we've done our conversion and done our migration to the 5069 and bring it up and running in run mode with the SDN enabled to run, I should see the same sequence of bits being transferred to those IO cards. Should see the lights blink. So from here, I think we're going to jump right into the actual process. As an overview, we're going to node commission the new 5069 SDN to its address of 62. We're going to use the existing program in the 1769. We're going to change the controller to a 5069 controller. We have to do that in order for us to be able to use the 5069 SDN. We're going to add the SDN to that IO tree. All of the code that's within the actual program running in the project file shouldn't have to change. The only thing that's changing is what's in the IO tree. We're going to save that project out. We're going to download it to the controller. Then we're actually going to go in and configure the 5069 SDN scan list and input and output tables to match what was in the 1769. And then once we've done all of that, we're going to put it into run mode, and then we're going to take the 1769 out of the loop. Once everything's in run mode and the SDN is enabled to run, we should now see the IO cycling like it did with the 1769. So jumping right into that, the first thing we're going to do is bring up the configuration, basically what's called the node commissioning tool for DeviceNet. That runs within this program that we're seeing on the screen right now is our RSNetWorx program for DeviceNet. I've already gone online and scanned my network very simply. Just to show you as an example of how that works, I'm going to go ahead and clear this list as if we just came in cleanly. I've gone in and in my network, I've set up my pathing to basically go through. I've got it currently, I think, going through my 5069 controller that I have online right now. But once the pathing is set up, you can actually browse the network, and it will go out and find every DeviceNet device that exists on the DeviceNet network. I actually have the U2DN sitting here. I'm not utilizing it, but you can see that it actually has showed up on the network as well. But you should see the 1769 SDN. You also should see the 5069 SDN. This is the guy that we want to node commission, change its address. You see it's currently 63. I need to change that to 62. So to do that, you go into your tools, your node commissioning tool, and you need to browse down to that device. So I'm going to browse. I'm going to go through my Ethernet. I know that this is my controller. Go to the back plane. I'm going to find that. You have to go as far as the DeviceNet. I have to go out to the DeviceNet port of that 5069. Then I can go and select the 5069, and you'll notice the OK becomes enabled at that point. I could have done this. I could have gone through the DeviceNet port of the 1769. You can go either way. But once I'm here, I can hit OK. It should make a connection to the device and show its current configuration. It says it's node 63 and running at 125. We're going to stay at 125K for our communication rate. But I want to just change its address to 62. I'll say apply. It'll say that it was commissioned. I'll close this. And just to prove that that worked, rebrowse the network. And we'll see what happens here. And you'll notice now the 63 node address now has a minus sign. No longer exists because it's now here. You can easily just go in and delete any device that shows up like that. I'm going to go ahead and save this to what's called a DeviceNet file or a DNT file. And I'm going to give it a different name. So I'm going to say File, Save As, and I'll call this one my 5069 SDN DeviceNet. And then it has a DNT extension. You can add it or you don't have to. Once I've saved that, I know I have this saved out. I'm in good shape. So at this point right here, I think I'm ready to kind of move on to the next step. Which is to actually take the existing controller program that's running for the 1769. I want to save it out to its own name, and I want to change the controller over to a 5069 controller. So we're going to switch over to the RSLogix program. I'm currently online with my project right now. This is a 1769 L36 controller and the 1769 SDN file. At this point, I can make sure, I can go ahead and save this guy. Just making sure I got it saved. Once I've saved it, I want to go offline with the project. So I'm going to go offline. Okay, we are now offline. So the very first thing I'm going to do is save this guy out to a different name. So I'm going to do a save as. And now, right now, instead of an L36, we are now going to be L3100 ERMS2. I'm just going to put L3100 here. And I'm going to change this to 5069. And what I like to do too is copy that file name. That file should be saved out. And then I'm going to go into my controller configuration. So you'll bring up the AOP for controller. I'm going to change this. First of all, I'm going to change its name. Okay, and I'm going to apply that. So what that does is you can see in the project it's now changed, and that should match up here. But I'm also going to change my controller. Here is where I'm going to convert over to a 5069 controller. And a couple things are going to happen. I'm just going to preface this. When I change that controller to the 5069, because of the way the I/O tree works, any I/O I've got configured like this 1769 SDN is going to be deleted because it does, 5069 does not understand 1769 I/O devices. So you've got the 1769 device here. You may have some other I/O devices. Those will get deleted when you've changed the controller. But I'm going to go ahead and change over to a different controller. And like I said, I've got a 5069 L3100 ERMS2. Okay, so this is a guy right here that I'm converting to. Also, you're going to have to ensure that you need to go to version 37 for the controller. I'll say okay to that, and it warns me about all the magical things that happen. And those are stuff gets changed, things get deleted. So once I've done that, you should see some changes occur over here in the IO tree. Once I've done all of that, I'm going to say OK. And so you'll notice now the IO tree has changed. No longer is there an SDN in this IO tree. We're going to need to add that. I want to go ahead and save it. Now, in your mind, you would think, okay, well, why not just go ahead and download it to your controller and start from there? And the problem with that is, if you'll notice, because I have a program that references some tags, these tags all reference some IO. Well, I don't have that IO here because it got deleted out. So I can't download this program to the controller just yet. But I'm going to go ahead and save it. I've got it named appropriately. I'm going to save this guy. Then I want to go to the backplane and I want to actually add the 5069 SDN to this backplane. So I'm going to say new module. And then I'm going to scroll down and you should see the DeviceNet scanner has our softening name, 5069 SDN. We want to just add this guy, create this guy. This actually will then bring up the AOP for the 5069 SDN. The initial page is the overview information about that, which is you've got your series, which this is a series A. It's a revision 1.01. We use compatible module electronic keying. We want to have both the data and status. The slot one, this is where I have it in my rack. One of the things to think about is if you put it in any other slot than where your SDN was in the 1769, we may have to make some programming changes to reference that IO. But in our current situation, we aren't going to have to do that because, as you saw the picture, they're both in slot one. I'm going to give it a name. I'm just going to call it SDN. You can do whatever you want here. The names cannot start with a number, and that's Logix in general. And if you want to put a description, you can. You don't have to. Once I've saved that, you should see the AOP for this. Once you say OK, then it's going to commit this to your IO tree. Once you've done that, we now have it in our IO tree. You'll notice the errors have kind of gone away. But if you want to just make sure, you can always go verify your controller. And I have no errors in my program. I want to save this. I now have this in my system. At this point, I think it's safe to say that you should be able to disconnect your current 1769 SDN. And you want to do that because it's actually owning and driving that IO. And we're going to actually make some changes so that now the 5069 SDN is controlling and driving that IO. So I'm going to just reach over here. I know you can't see it, but I'm going to unplug my 1769 SDN and my IO will stop blinking. All right, so once I've done all of this, the program is ready. I need to download it to my controller. So I'm going to go through and make sure that I'm pathed to that controller. And I actually currently, it looks like it's pathed to this 1769. I want it to actually go to my 5069 controller, which is right here. I'm going to set his project path so that he is mapped to my 5069 controller. And then I'm going to say download. I'm going to actually overwrite the existing program in that controller. It has no errors, so it's going to now let me download. Okay, looks like we are downloaded. We are online. We are in program mode. Let's stay in program mode for now until we get some of this other configuration done, and then we'll be ready to put it in program mode and actually start the SDN to scanning. So now that we have got the new program downloaded, we need to go back to RSNetWorx and make some configuration changes there. So I'm going to bring back up the RSNetWorx program. One of the things that I didn't talk about early on, I should have, was it's important to go ahead and generate a report and what it does on your DeviceNet network. I'm going to do it for the entire network. This report is good to have. This gives you an overview of your DeviceNet network, what all the devices are, each device and its configurations, so that you can recover this at a later time. Let's say you lose your DNT file, or you don't have an online access to the machine. This gives you the configuration of all your devices. Also gives you a configuration of the IO tree. Now, in this case right here, the 1769 SDN scanner module, you can see configuration. It has a bunch of IO that's mapped to it. It has all the devices that are in its scan list. So all those important things that you need to consider, this report will give you that information. So at this point, what I want to do is I need to get this guy configured as I had this guy configured. you can do the IO tree a certain way where you can just have the system, when you add modules to a scan list, it's going to add them to the IO blocks in a contiguous manner. Open this guy up and go to his, let's say, his input memory block. I'm going to upload from the machine. It should not have any configuration in it right now. But if you'll see, you've got all of these. In our case right here, we have 116 bytes of data that we can use within the machine. And each of these indicate a mapping of IO data from devices that are in the scan list. I like to go ahead and do, so if you go into the options menu and select this Dword-aligned, say, okay. What that does then is every time you add a device, it is going to get mapped into the next Dword. So I'm going to apply that. So what that allows you to do is if you only have a few devices, this is a good way to kind of keep your mind straight. Is for each device on the network has its own 4 bytes of data assigned to it, and so you don't have to sit there and do bit masking off of these actual IO points here. So you can access the first device in the network's inputs using array index 0. Actually, probably wouldn't hurt for me to do that right now. So if you look at the controller tags and you look at the input tags for the SDN, and so the way you get to that, if you look, since we're in slot 1, we want to look at local 1, which is slot 1, and these are the inputs. If I expand that out, I have status register information about those inputs. This looks very similar, if not exact, to what you see in a 1769's IO mapping. But in the data, you'll notice that each of these dents match. This matches what you saw over in, and I'll go back to RSNetWorx, what you see here in RSNetWorx. That's the correlation of what those are in the system. So if I know I can deal with my first device at address 0 and my second device at address 1, it's easier to deal with a single tag than it is to take this tag and try to break its bits apart and figure out whose bits are what and do masking and what have you. It just makes a simplification of the programming. So that's why I go to Dword methodology. So I've done that. And that applies, once you do that, that applies both to your inputs and your outputs. You'll notice it's Dword-aligned also. If you change it in one place, it's going to change it in the other. So now, more importantly, we need to look at our scan list. So if I pop over to my scan list for this device, currently there is nothing in the scan list. I'm going to add them all at this point. So now all of them are in the scan list. I'm going to apply that. Okay. So once I've got the scan list set up, I want to go to the input mapping. And now if you'll look, it has mapped each of these in their own in their own memory location. Interestingly enough, if you look at this second device, okay, this 2-point analog card has a lot more information than just 1 byte of data, 1 byte of information. Okay, so because of that, you have to you look at it. It goes actually across 2 of these memory locations, so to speak, 2 of these Dwords. All this is O2. It actually has 48 bytes of information that it has in there. And if you want to know what that information is, you can expand this out and it will show you on the device what each of these, the actual meanings are. So there's 2 bytes of channel 0 data, channel 1 data. So that's the way things get mapped. Now, in my situation here, the 2 cards that I'm really concerned with, that my program is concerned with, are the 2-point IO cards. There is a 4-point and an 8-point IO card. So I'm accessing those bits, and those are at memory location 0 and 3. And when we go back into the program, you'll see that here in a minute. I'm going to go ahead and apply this so that all of that is set up. At this point, too, I also want to make sure I've got everything saved here. So what I'm going to do is I'm going to say upload from network. And I'm going to bring all the information about these back up into my DNT file. I just want to do this one last time so that I have this saved, and then I'm going to save the file out. I'm going to go ahead and save that file. Okay, so I've got this saved, and I think we're pretty much done with RSNetWorx for right now. I'm going to go back to my program, and as I was telling you, if you'll notice, these are the memory locations, the input memory locations that I want to deal with, but I also want to deal with my output locations. So you'll notice there's data for this guy. Address location 0 for outputs is for the 4-point card, and 1 is for the 8-point card. And if you'll notice, you'll see this guy 01 and 03. These are the MAC addresses, okay, for the devices that actually map there. So I think we're good. So I'm going to go back to here. I should be able to go ahead and put this into run mode. All right. It should go into run mode. I should not have any errors. And you should see that these values are starting to go up. And if I were to look at the controller tags, you'll notice that these guys, the different bits of location 0 are going up, basically 0 to 255 back down to 0. The interesting thing is, if I look over at my point IO module, for some reason, my lights aren't blinking. And that reason is, but there's one other output that I have to set on my SDN, and you would have to do the same thing with the 1769. I need to tell this thing to go ahead and run the IO. So when I toggle that bit, now all of a sudden, my lights are blinking. Looks like everything is working. If I want to, I can disconnect the 5069 SDN, plug in the 1769 SDN, it'll recover and actually start toggling the IO as well. And that'll prove to me that these two programs are working exactly the same. At this point, your machine is ready to go.